record it. Okay. Yeah. Access the media. So just listen how if one particular person accessing through desktop and another person is accessing through laptop. So accessing the media, you all know through any network, it will be converted. Okay. So when you see that, if it is the desktop, it will be connected through LAN cable or Ethernet. Okay. If it is a laptop, it is connected through the Wi-Fi module, broadband module. Okay. So here, while I'm seeing that framing, I am telling now IP packets, segments we have seen there, but when you see that, that head and trail will be attached here. Okay, so will you see that for each and here head and trail along with the IP packet, along with the IP packet. So through this, I'm sending the message from laptop to this desktop. Now the connection is through that. Will you see that head and trail? We all know that it is having how it is accessing the media. That is there. It is attaching with head and trail with IP packet. Next, control how data is placed and received from the media. Okay, you all know we have this particularly this data link layer is responsible for MAC address, MAC media access control address. So here that particular data link layer, we all know the communication be through a LAN cable, or it may be through optical cable, or it may be through Wi-Fi or radio connection and all. So this particular data link layer, it is checking through which cable the communication is happening, whether it is through LAN or it is through optical or it is through the air medium. So this is, we used to say CSMA, carrier sequence model access. So through that, it will always check at which, through which the data link layer is the, so it is responsible for access the media. And the next responsible is how the data is placed and received from the media. So that's why here this data link layer, we always include the MAC address. Okay, media access control address. So here you have to understand it have a both head and trail. The two purpose it is saving. Access the media and how at which media it is receiving as well as accessing. That is, it is focusing. Okay. Have you understand this point? Students, have you understand this point? Have you understand?
Yes, ma'am.
Yeah. So we will move on. I told you now head and trail and all. So you have to understand the network layer, which is responsible for logical addressing. Okay, and the data link layer is responsible for physical addressing. We were saying that we all know that it is split into segments and it will be split into bits and all. But here it will address, it will give the MAC, media access control address here. Okay, and IP address, that will be given, the logical address is given by the network layer, but this physical layer, physical addressing, the data link layer will look up through whether the communication is through LAN cable or the communication is through fiber cable or it may be through Wi-Fi. That and all it is focusing and it is sending. Is clear? So here what we are saying now, MAC and all now, the full form of MAC you have to understand. It is a media access control address. Okay, and mainly network interface controller is used to assign this media access controller. So IEEE 802, we all know that using standards only we are all doing this communication and all, so that whether it may be through Ethernet or it may be through Wi-Fi or it may be Bluetooth, it will check through at which media access this will be done. So data link layer is always responsible how I am sending my message, how I am sending my frame. Okay, and which media I am sending, this is the thing. So through IP address and segments will be there. Along with that, what is attached here? MAC address, that is head and tail will be attached. The entire thing we used to say frame. Have you understand? The entire thing we used to say frame. The word we are using now, frame, you have to understand what is the MAC address now. It's alphanumeric address. It contains both alphabetics as well as numeric. But when you think about logical address, it purely a numerical only. But MAC address contains alphanumerical address. Have you understand what I told you? So the segment is done by that Are you listening, people? Yeah. Are you listening? Okay. So here, this IP address, which is the responsible by the network layer, we are saying now, and the segments are done by the transport layer. And by combining this, we are used to say data packets. But combining with the MAC address, with the head and tail is attached, that is said to be as a framing. Yes, clear? Have you understand? Have you noted down this? I think I'm not audible. Okay. Shall I move on to the next one, Ma? Have you understand what is the purpose of this data link layer? So for you purpose only, I put it all this. Now you just see network data link layer. So we all know net data link layer is a interface layer between the network layer and a physical layer. We told that it contains both head and tail with that. So that word we used to say frame. Why? Because frame na MAC address is attached with the IP address and segments, and which is forming. So it is always check through which media it is sending and how it is communicating. So data signal, that's why we are saying that electrical signals in a network. What is electrical signal now? For example, if I take LAN cable, that are like a electrical signal. Electrical signal means how we used to say na, you have drawn na, it's a pulse like signal. So we used to say this is 5 volt and this is a 0 volt. Okay, when the values are ones and zeros. So it is an electrical signal. When it go with a fiber optical cable, the communication will be happen through the fiber optic cable. And sometime it may be through the air medium, that is Wi-Fi we will say. Or that data link layer, it is mainly used to check the size and format of the data, and through which media we are sending the data, and also always it will checks with the error and control scheme. So mainly it is also responsible for sending the data, but sending the data in which form? In the form of frames. In the form of frames. So data link layer is mainly responsible for sending the form of frames. Is clear? Have you understand? So I think I told you this is one of the important PPT. I think you may take it. You should not forget this. Is clear? You
Ma'am,
should not forget this. So data, segments, packets, frames. So data link layer, it always, yeah, someone call me ma'am.
ma'am, once again show the data link layer diagram, ma'am.
Yeah, I will show you. Okay, so these two are responsible for handling the data. Data is splitted into segments. By attaching the address, it become a packet, but attaching the MAC address, it becoming a frame. So you all understand this 7 layer name is important. Similar way, this is also very, very important. Yeah, yeah, ma. Which diagram? This diagram, or this diagram? Which diagrams are?
Previous,
Huh?
previous diagrams.
This diagram. Am I
Yes,
correct?
yes, ma'am. This.
Yeah, yeah.
Yes, ma'am.
Okay. Actually, today I will complete all the 7 layers. So today I will upload this OSI model PPT here. I think I have sent you the book textbook because that I can't able to upload in LMS. That's why I keep it as a in a form of I have sent to the in WhatsApp to Sagar. I think Sagar you have uploaded in your group.
Yes, ma'am.
Yes. Okay. So the first 3 layer are responsible for data, and while it comes to the 4th layer, it becomes in the form of segments. At come to the 5th layer, it becomes in the form of packets, and into the 6th layer, it becomes in the form of frame. And the 7th layer, it is actually while I'm coming top to bottom, I'm coming, but it always starts from physical layer only. Physical layer is the first layer. Okay, we will explain that only. Okay, I think you may remember the alphabets. Okay, physical layer, data link layer, network layer,
transport layer,
transport layer, session layer, then
presentation
presentation
layer,
layer, application
application
layer.
layer.
This 7 name you have to remember. Starting from this is the first layer and this is the 7th layer. Yes. Yes. Have you drawn this diagram? Ma? Have you drawn this diagram?
Yes, ma'am. Yes, ma'am.
Okay. So I think this diagram is helpful you to understand what is data link layer, access the medium in form of frame and through which medium we are accessing. So that's why we told you that MAC address, it's a alphanumerical address, head and tail will be attached. It looks like a frame structure. Okay. Now I think I told you again the same thing, data link layer. Okay, NIC we are saying network interface controller. Here we are saying the network interface controller will identify through which medium we are getting this frames and all. So this is the hardware part of this network interface controller. You've seen that while I'm communicating from one system to another system, the MAC address through that, whether it may be through LAN. This is the symbol for LAN. LAN. It is electrical signal. We used to say LAN, and this is what? Fiber optic cables. The communication is through fiber optics, or it may be through the radio communication. Okay, it's maybe a radio communication. Yeah, so mainly this network interface cable will identify through which medium I am receiving this frame. That will be identified in the data link layer. You all understand that just communication, how the 7 layers are very important. That's why we cannot able to hide any detail whom sending and through which IP address I am receiving. So through that it is now the communications are easily identified. That's why that such a OSI model is very important in this subject. Okay, that's why we are learning this computer network as a separate subject. Okay, yeah, okay. Now I will move on to the next one. I think I think this is the theory it is giving. Okay, so told you framing. So divides the stream of bits from network into manageable unit or called the frame. So you all know that source address and destination address will be there. So it is used to connect from one network to another network. Okay, and data link layer is also responsible for flow control and error control. So you all understand that flow control, you always the meaning of flow control now. For example, my speed is 10 mbps. Okay, and you all know my speed is I'm getting by 10 mbps. Okay, my okay, but I'm getting this data by 100 mbps now. My flow control will inform the servers to slow down that, just slow down, because my speed is not matched with the server speed. That is flow control. Okay, so flow control, it's always to that my data should not be lost and all. So for that I will do the flow control and all. For example, my speed is 10 mbps. I am getting my speed as a 1 mbps. So at that time we will ask you to increase the speed. So this is the way we used to say flow control and all. So flow control depending upon bits per second. BPS means you all know, kbps na kilobits per second, mbps na megabit per second. So you have to understand how long I am receiving my data from the server. Depending upon my data speed, my timing, I have to communicate with my server to match with my flow control. That is flow control, the word, the meaning. The error control. What is error control now? We all know that while I'm sending the data, we all have a synchronizing now, the last of data should not be there. So when the data will be lost now at two circumstances. One circumstance, whether it may be a online video streaming and all, we cannot able to get the data, because we all know that it's online video streaming, whether it may be in the form of mail or it may be in the form of images and all. We should not lose any data, so that we always have a, while I'm converting, it should be an a synchronized, so there should not be error and all. While I'm converting in that, it will has to check the parity, it has to check the error having code, so that this data link layer is also to be responsible for flow control as well as error control. Yes, have you understand the meaning of flow control and error control? Okay, this is the way we are saying that data link layer. So while I'm sending the data link layer, my source address and destination address will be there. Okay, okay, it's not like a network layer. We have a routing, path formation and all that. Here the source and destination address will be there. Head and trail will be attached to that along with the IP address, and that entire thing we used to say now, segments along with IP address and segments, it is like said to be as a packets. Okay,
Ma'am,
so
what is
that,
the function of trailer, ma'am? Why the trailers are attached?
okay, while you understand that not only head address and tail address, you have to understand I'm sending my data now. It is sense that my start bit, stop bit we are used to represent now my data get over. That's it will be sent. So how the address is very important. The similar way, this is the last data. So this is my stop bit. That and all to be understand by that, we are sending the head AU as well as trailer, the end of the bit, to understand that. This is not end of the bit, it is the end of the communication. EOC. That is why head contains the address information. Trailer contains, it's like a stop bit. Yes, Sagar?
Clear, ma'am.
Yeah. So next come to the physical layer. Okay. While coming to the physical layer, I will go to the diagram later. Okay. Now you just see this. This is our this three layers. Actually, the no, these three layers are very very important. Not all the 7 layers are very important, but while we are saying now, my data is splitted. That is segments, and this network which has contained the source IP, destination IP, and segments. And while it comes to the data link layer, we are contains this MAC address and all. Now, what come to the physical layer, it becomes what's ma? It's become bits. You all understand? It becomes bits. While it becomes bits, you have to understand contains. It contains ones and zeros only. So whether we have already discussed about that LAN cable, whether it may be a fiber optic or it may be a radio medium, whatever may be, that bits will be sent through this media, and that signals, it's converted again into bits, and again it passed through data link layer, network layer, transport layer and all. We all know that a session layer and all, it will be transport. Again it will comes to the application layer. Once it comes to the application layer, the receiver will receive the message from that application layer. So you understand that whatever may be that segments, packets, MAC address, whatever may be, that will be finally converted into bits, and that bit will be transmitted through the medium, and then finally it goes into this, again this all 7 layers, and then it finally reach the receiver ends. That is my application layer. So this is the figure you have to understand. Okay, have you understand how it will be
Ma'am,
sent?
just give us 2 minutes, ma'am, so that we
Yeah,
can draw it.
okay. Yeah. So I think yesterday so many things you may got. So that's why I want to put it some physical image. You may understand well how it is happening. Okay. Still some, actually I will update the attendance on daily basis. 2 more days attendance were left. Today I will update again Some of them audio is not connected. Okay. So all the layers are working behind, but these people didn't want that audio signal. Only they need video signal. That's why Vijay Srinivasan, Devi, Sridharan, Uday, Akshay, Abhinaya, Abhishek. I think in this class only I got some girls were doing like this. Normally, okay, okay, ma. Have you written? Have you written, ma?
Yes, ma'am.
Okay. Okay, I think I will go to this main diagram. So physical layer, they were saying that bits and transmission media, whatever may be the media. So physical layer, it's saying that whether it may be in the form of wires and cables, it also handles the electric signal, the transmitted data throughout the network. So it defines the logical level, data rate, at what speed it is converting, and physical medium. Everything will be that whatever may be the packets or segments, or it may be contains the bits, that finally when it comes to the physical layer, it will be in the form of bits only. So through that it will receive, and once again it will be sent to the data link layer. So you all understand. So far we have seen from this to this is my interface layer, we used to say, but here interface layer is nothing but transmission media. Is clear? While I'm saying about my first layer, we used to say the data link layer. Okay. And there will be an network layer. And transport layer, na, the network layer will be the interface between the transport layer and data link layer. But here, when you go with that, there is no interface layer, but the transmission medium. Here there is no interface layer. The transmission medium will be the connecting between these two layers, and where my communication is there, it mainly handle the electrical signal, how it have a higher value. This is all the value of ones and zeros and all. It will transmit. It depends purely. It is comes under the communication purpose. How the data will be transported from through the transmission medium, that we have seen in the physical layer. Okay. Okay. So while it comes to the physical layer, what it responsible now, it coordinates the function required to transmit a bit through a physical medium. So it's mainly deals with mechanical and electrical specification. I told you that fiber optics and LAN cable and Wi-Fi, there will be a specification for ones and zeros. There it will receive the bits, and it defines the characteristics of interface between the device and transmission medium. Okay, I told you the interface medium. So far we have seen the layers, but here the interface medium is a transmission medium. Interface medium is the transmission medium. There are different types of transmission mediums are there. Define the data rate, number of bits each per second, and duration of bit, how long it lasts. That and all will be taken care by this physical layer. Okay. And you all know physical layer is also responsible for synchronization of bits, topology, and transmission medium. We all know what is simplex, half duplex, and full duplex, ma? Simplex, half duplex, full duplex.
Simplex only one-way transmission.
Uh,
Half duplex a two-way transmission, but via one wire. Full
okay.
duplex two transmission via two different wires.
Yeah, very good, very good. I think what he said is simplex, half duplex, full duplex. I think I will show you the image. I think he is remembering what I told you. I think already it's not a one, it is a basic one only. Direction of data. Okay, simplex, half duplex, and full duplex. All this communication will be taken in the care of our physical layer. So you have to understand how the direction of data, and how the direction of data will be one at a time, only receiving part, or you will receive or you may transmit. If you do in both, nowadays we have only the full duplex mode of communications, but nowadays insane I'm telling in the internet protocol. Okay. Okay, I think I think we have told you about two layers today we have seen. So I think this is the entire layers diagram. This is 7 layers diagram. So I think a small recap, and then we will see to that, and we will move on to the next layer. So application layer. So you all know a network one will connect with network two, whether it may be use different types or it may be use a different operating system, whatever may be, it's a network application. So mainly it is a application layer, whether I will do file transfer, web surfing, emails, or virtual terminal. So some of the protocols you have seen this. These are the 4 protocols which is supporting this application layer. So each layer we have now, it have a own responsibility and it have own protocol. So that's a rule will be governed by that. So file transfer, for example, for FTP will be there. When you go for web serving, HTTP protocol will be there. When I go for email, SMTP, okay, simple mail transfer protocol will be there. If it is a virtual terminal, on that day you have told you Telenet and all will be used. So TeamViewer, AnyDesk and all, like a virtual terminal connection. So application layer, whoever that network through my application to server will be there. So some of the protocol it is responsible for file transfer or web serving, for email or virtual terminal. Some of the protocols are very responsible to communicate from my system to that particular application layer, and definitely the server will be there and protocol also will be there. So we all know that DNS, that is a domain name service and all, sometimes it's not be available and all. So at that time we cannot able to communicate, even though the entire layer we have a communication, but if particular server is down, we cannot able to access that application. Okay, when you go for the presentation layer, we told you that presentation layer will take all the translation, data compression, encryption and decryption. Okay, so whatever may be that ASCII codes, that will be, we all know what is the full form of ASCII, ma?
American Standard for Information Interchange.
Yeah, EBCDIC. Did you hear about that?
No,
Extended
ma'am.
binary coded decimal interchange code. So again, whatever may be the ASCII code, EBCDIC. I think in digital, I think you may extended binary code. This is also there. I am converting all this ASCII code into that. So this particular layer is responsible for translation, data compression. You all know, while I'm sending my 5 MB file, when you compress, you all see that 2 MB, that will be a data compression. They are saying lossy, lossless. Online streaming and all, they, depending on your time, it may be a loss will be there. If it is maybe in the form of images or text, you will receive it without any loss. Okay, and encryption and decryption. You all know my data should not be theft. So all the data should be, while I'm sending, it will be in the encrypted form, and while I'm receiving, it will be in the decrypted form. So definitely there a secure socket layer is responsible for that. All this translation, data compression, encryption and decryption will be done in the presentation layer. Is clear? So whatever maybe, it will be converted into the binaries, and again it will be compressed and it will be encrypted, and then I am sending to the next layer. So this is the responsible for the presentation layer. Yes. Then session layer, while we seeing about the session layer, so we have a 3 purpose of the session layer: authentication, authorization and session management. All this will be taken care of the session layer. So authentication, we all know, we are putting our username and we are getting password now. That is authentication to enter into my mail. And authorization, which is given from the server to access the image or text or file, whatever may be, that is authorized by that. And session management is also there. So we all know the text will be converted into one data packets, images will be converted into another packets. So all this will be done by the session layer. So session layer will do all the session management. The one best example we are saying that how we have so many workers there in our campus. These are responsible for taking classes, and these are responsible for cleaning purpose, and these are the staff which is responsible for technical handling the lab and all. The similar way, the session layer which is responsible how we have to divide that packets and through the web browser. All this session management will be taken by the session layer, but obviously it give the authentication and authorization. So depending on the worker we are assigning now, the similar way the session layer which is responsible for this kind of work is clear. Okay, and transport layer, we all know transport layer is nothing but with all segments. My data will be divided and it will be into that is segments. So whether it will all represent sequence number, port number, data will be there. So depending on the port, it will receive sends to WhatsApp or Mozilla Firefox or whatever maybe Chrome and all, it will be there. But entire thing will be segmented and it will be in a single form of data also it will be sent. So segmentation will be also take for this purpose. Transport layer, you all understand, segments, data will be divided into the flow control, error control. I already told the meaning for flow and error will be the two things. It always checks with the speed and it always check without any error. I have to receive the data. And they are saying that connection and connectionless, UDP, user datagram protocol, and connection oriented na TCP. I think this particular first unit, we are going to see about the TCP IP protocol separately. Okay, so the transport layer, the two protocols are very, very important, UDP and TCP protocols. So again, I'm saying error control. While I'm dividing my data into small, it will always check with error correction, check some corrupted and all. That and all will be done by the error control and flow control. Okay, this is the meaning. If I'm receiving 10 Mbps, this will communicate to the server to slow down or to increase the speed depending upon my speed. That will be because it is delivering 100 Mbps. My phone is receiving 10 Mbps now. The transport layer will take the responsible. So all the layers, some of you all seen data link layer and transport layer doing this flow control and error control, but the meaning for this will be same meaning only. Okay, so what transport layer will do now? Divide the data segments, flow control, error control, and then session protocol, transport protocol also very important. Then the network, we all yesterday we have seen one thing. Network will always do three work. One is logical addressing, and another one routing, and path determination. Okay, so logical address, it all we have a IP address and all. So for each and every system we have a own IP address. Okay, and a path determination, how far I have to send my through data. Okay, all this protocol will be behind that to set the path. Okay, so path determination and routing. So network layer will take all this purpose. So very one example they were telling, if it is a Facebook server, this network is accessing the Facebook server, and automatically Facebook server is receiving two address. Okay, so 192.162.2.1 and 3.1, there it will comes to here, and it will check, it will receive the packet, and then it will identify which network is asking, it will send to the particular network. Is clear? So this will be done by the network layer. So there will be some mask is also there while I'm sending. Okay, so network layer, you all understand, it is serving three purpose: logical addressing, routing, path determination. So whether yesterday we told you virtual circuit identifier, incoming port, outgoing port now. So where I'm receiving my data, where at which port I have to send, all this will path will be, shortest path will be decided by that, and network layer will take responsible of that. Okay, have you understand all these layers? Any doubt in this particular layer? Have you understand all the 7 layer purpose? Shall I will put it over? Have you yeah, any doubt on the any
yes,
layer?
ma'am. A few features of data link layer is similar to transport layer, like flow control and error control. And why is it so, ma'am?
Transport layer and data link layer. Okay, while I'm coming to the transport layer, transport layer, there we are putting our IP address into the segments, and we were sending the, while it comes to the network layer, we are putting the MAC address and we are sending. So every time while I'm adding my data should not lost. And as well as here, MAC is responsible for media, okay, and IP is responsible for the network. So their flow is also very, very important. For example, when you go for fiber control, the speed will be very, very important. While I'm coming to the IP address, whether I'm sending my data through UDP, user datagram protocol, transmission control protocol, whatever may be, again the flow is very important. So what is that saying now? Here, data link layer through media I'm saying, and transport layer we are saying in terms of network we are saying. So in both the way, it is concentrating on media, na? It is concentrating on the network. So their flow, it's very, very important. Okay, so that's why both are focusing on flow control. And network, again transport layer, we are adding the IP address with segment. Na? My segment should not last. So it is focusing on the error flow control. Here I am adding over the MAC with the segments. So again, the error flow control is very important. So because the other layer, whatever may be, it is not adding anything. It is converting the data into segments into bits. But here it is adding one more thing to the data, that is address. So while I'm adding my address, you all understand it should not lost the data. That's very, very important. That's why this two layer is all responsible for the flow control, as well as it will checking the error control. Is whether my answer is justified for you?
Yes, ma'am.
Okay. Okay. So I think I will put it over and I will upload this. That's why I put some images. You may understand well how it will takes this. And this is the thing you may ask the meaning, some protocol expansion and all that we will see to the protocol, but entire OSI reference model. If you see to this particular PPT, you may understand to write one part B question, explain OSI reference model in detail. So this all, you all understand this application, presentation, session, transport, network, data link, physical. I think this purpose you may read. Interface to end user, then interaction directly with the software application. That's why we have seen Wi-Fi, Mozilla, Firefox, Skype, Chrome, and all, which are less responsible to access from the end user. And you all know software app layer, all this FTP, HTTP, SMTP, all these protocols are responsible for the application layer. So presentation, while coming to the presentation, we all know it is doing the data transmission, it is doing the translation, data compression and encryption, decryption. All this value works are done by the presentation. So definitely the terminology, syntax and semantics will come over here. That are the key elements of the protocol. So syntax means this will be the syntax. While I'm taking my system, while you see that it's a 64-bit system now, what will be the syntax I have to follow? According to that, my presentation layer will convert that into that particular bit, and then it will do all the translation, compression, encryption, decryption, and formatting. Syntax, I told you na, syntax means, you all know if language na, you all know if the condition we will write, if the condition is there, else we will print the next condition. That is the syntax. The similar way here also we have a syntax. But when you go to the semantics, what is the meaning for semantics, ma? Syntax is nothing but how my data should be formatted. That is syntax. What is semantics? What is the meaning for semantics? You forgot. Meaning for each and every bit. That is semantics. Meaning, we have seen that in the uh, physical layer, in the protocol, we have seen that three key elements: syntax, semantics, and timing. So syntax and semantics means
Ma'am, can we
the,
say that semantics are grammars?
yeah, that is I think Sagar have that doubt. Semantics is a grammar. What is that meaning? The similar way here, it is the gives the meaning for each and every bit. That is semantics. Did you remember? Do you remember this slide? First day I
Yes,
have
ma'am.
taken refers to the meaning of each section, how particular pattern to be interpreted, and mainly to that the address will be identified. You all know which is address, which is and all. So that is semantics. Yes, you have to understand what is the meaning of each and every bit. That is semantics. That you told grammar, na? That grammar is semantics here. So you see to that. Okay. I think on that day I put MAC address and IP address. So I will go to that PPT. Okay. Then session layer manages connections between local and a remote layer. So I told you session layer is responsible for authentication, authorization, and session management. So how my packets, whether it is a text packet or image packet, whatever may be, my session layer is a establishment to that all the login authentication, all session management will be taken care by the session layer. Okay. Then transport layer, that these are the protocol are responsible. This gives the protocol which is responsible for each layer. Then transport you told now, end to end, the meaning transport. Okay, that's why it always, you all you asked one doubt, Sagar, did you ask now? Checking, error checking and all, flow
Yes, ma'am.
control and all, data segmented, reliability, multiplexing. Okay, that CSMA we used to say, carrier sensing multiple access, connection oriented, whether it may be using UDP or TCP and all everything will be comes under the transport protocol. One best example, they are saying UDP, it's they are using online stream and all, whether you are receiving or not, it's not my problem. I keep on transmit, that is UDP. Okay, nowadays the lecture is also become like that. Whether you are listening or not, I'm keep on talking. That's why I am putting a break like a TCP protocol, and I am asking the acknowledgement from you. Okay, whether you have understand or not, I cannot be like a UDP. Sometime I have to be like a TCP. Okay, that is the meaning of that. Online streaming is like UDP, and TCP always have a feedback that you have received, and that is transmission control protocol. Okay, then while coming to the network, all we all know that now logical address will be added into the routing. Path determination, you all know, understand. Yesterday I told, that's why I have explained you. I thought that some of them cannot understand, that's why I changed the image, because it's purely in the point of electrical point of view I have explained. I think you are the IT people, that's why I changed. So that when you understand that um, path determination, routing, and logical address, that and all will comes to the network layer. Okay, then switching, and you all know, defines the format of data on the network. That's why it is also doing the error checking. Okay, encapsulation, frame traffic control, that is flow control, MAC addressing, all will be taken by the data link layer. And physical layer transmits raw bit string. They were saying the meaning raw bit, that means it is a bits, it will be transmitted into a bit. They are saying it may be a mechanical or electrical signal, but it is a physical connection. So I think if you understand this particular slide, you may able to write this question well. Okay, so you all know this three odds mentally carries the data. It's all concerned with the data, and this comes to segments, and this comes to packets, and this comes to frame, and this comes to bits. Will you remember this? Why I'm repeating same thing now? The entire 7 units we are going to study this only, but now have you understand this? Yes, shall I finish it, this OSI model here? Any
Yes,
doubt?
ma'am.
Okay, okay. So I think we will go back to our syllabus. Okay. Actually, ma'am having hours on the same time, so otherwise, that's why she didn't come. introduction to data communication. Okay, that's, we have seen how the broadband connection and all, network protocols, okay, standards, line configuration, I think the line configuration, I will touch it over here. Okay, is said to be covered. Topology we completed. Okay, transmission medium, that is also to be covered. Okay, categories of network, that is also to be covered. Okay, we have come into the OSI model, layers of OSI model. This only we completed. Is clear? We have completed introduction to data communication, network protocols, standards, topology, OSI model, and layers of OSI model. Have you understand? These are the topics we have covered. Is clear? Any doubt on this? So why I have touched this OSI model now? You may understand this 4 layer we were going to study: data link layer, network layer, transport layer, and application layer. What layers are not covered here? What layers are not we are not going to study in detail? Okay.
Application presentation layer.
Presentation layer not covered. Okay. Presentation layer is not covered in the unit. Okay, then tell me. Then what is the next layer? Session layer is not covered.
Physical
Okay.
layer.
Physical layer is not covered. These 3 layers are not covered. Why? Because now we were simply saying presentation layer. Presentation layer, we are saying that my data will be converted, ASCII is converted into EBC DIC. Okay, data translation is there. Then we are saying data compression is there. Then we are saying encrypt and decrypt is there. So that is, we are saying that all done by the presentation layer. Okay, and the session layer, we are saying that authentication, authorization, and session management will be done in the session layer. And physical layer, we are saying that through the medium we are transmitting. So when you see that this physical layer is covered here, like transmission media, guided media, unguided media, all will be covered here. Okay, and this authentication and authorization, did you studying any subject related to authentication, authorization, data management and all?
No, ma'am.
Ma'am, database transaction control.
Yeah.
Yeah, I think cyber security you will study, database management you will study. So at that time you will understand that. Okay, and similarly, presentation layer we have done 3 purpose we have seen. Converting the code, I think you are all studied in digital, and while you seeing compressing and encryption decryption, again data cyber security will study. So we cannot able to this 3 layers in detail. That's why the remaining 4 layers we were studying in depth, and we will see how this flow control is there, how we are simply saying in the word now, how this and all will be done, and what are the protocol and how it all responsible, that we will see in the other 4 unit detailed about other 4 layers. Yes, yes, students. That's why
Yes, ma'am.
I'm saying I'm not a UDP, I'm a TCP. That's why I'm asking. Okay. Once again, today I will tell you how your communication is happening. Okay. Okay, I will share you one. Yeah, data communication we were saying now. Just a small thing, but anyway, we already spoken how the data, how they were calculating and all. Okay, it's a data is transmitted between 2 devices via transmission line. whether it may be a wired or wireless transmission. Okay, data may be a text or numbers, or it may be audio or video in terms of data. In terms of components, it may be a message or transmitter or receiver, transmission medium, and the protocol will become effect of transmission. Okay, delivery, accuracy, timeliness, and jitter, that all we have to consider while I'm doing my. So while comes to the
Ma'am,
data,
what is jitter, ma'am?
yeah, while you seeing that, we are saying that my data should not be corrected, my data should be delivered properly. That's very important in the transmission, that they are saying in jitter. Okay, so this are all about effective way. Okay, data should not be lost, and data should be represented the way and the component. So this are all in very important in the data communication point of view. Okay. Okay. Now data, they were saying various data. Data means it contains zeros and one. It contains unstructured data or semi-structured data or structured data. They were classifying. Digital signals, na, a signal which is the original information is converted into a string of bits. We all know this is analog signal. Okay. Any signal which have the waveform having a, that this you used to say analog is a sine signal, or when it comes to the digital signal, it contains the zeros and ones. Okay, why digital signals are very popular on communication? Now, it can transmit over a long distance and the less noise will be there. When I'm taking analog signal, it having a frequency. So my normal frequency also will be superimposed in the analog wave. That's why the digital signals are very popular for sending over a distance and less noise. And examples, what are the examples? Now, computers, digital pens, digital phones, and all. Okay, so these are all about data. Okay, and then next one is bit rate. I'm saying bit rate now, bps, bps, bps now. What is here now? Bits per second. I told you how to check the bits per second. So normally nowadays we are transmitting megabits per second, not kilobits per second. Even the time when you see that the modem, they, even the service provider is same. The modem also we keep on updating due to the bits per second. We were saying that this is megabits per second. Okay, even 2 to 3 years you are using the same modem, they will say that I think now it's not happening. When 2015, while we are using from 10 to 15, they changed the modem. Madam, sir, we have used this for a long time. Okay, they have changed because now we are all getting our network speed in Mbps, and normally BPS represents bits per second. Okay, a good rule for thumb for bit rate is how they were saying your bits per second. Now that calculation is there. Okay, you just see this. Okay, you may take it. Actually, it will be somewhat related to technically frequency and all we used to say. 44,100 samples per second, 16 bits per sample, two channels. Now this is the way they will calculate the bit rate: samples per second, bits per rate, and the channel. So this bits now, then normally they convert 1411 kbps. Okay, or else we say 1.4 mbps. Nowadays they are saying, I think you people will face the problem while you are writing your exams, online exams. You have to be use only the broadband connection, because that will deliver you only in mbps and all. So on that day also I have shown you how to calculate that internet speed. So baud rate means number of signals transmitted per second. Actually baud rate and bit rate both are same only. Okay, how long it is transmitting, baud rate is very very important on communication. Okay, how many bits transmitted per second. Okay, bit length, what is bit length na? Speed into bit duration, that is bit length. I think that's not needed for you. Whatever you needed, that alone you may take it. Okay, this is bit interval. You understand? I'm saying now ones and zeros, because you all understand we are sending a digital signal. How many bits are here, ma? How many bits are here? In this image, how many bits we are having? How many bits we are having? Students, are you there? How many bits are here? Yes, I think I am not audible. How many bits are here?
8, ma'am.
Yeah, correct. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there. Okay. And what is the interval? 1 second they have given. The bit interval is 1 second. Okay. And how many bits are there? 8. So what is the meaning of that now? 8 bits per second. 1 second equal to 8 bit interval now. 8 bits per second it is traveled. So you all understand? 1 means it's having a high voltage. 0 means it having a encoded as a 0 voltage. So this is, they are saying 5 volt. When you take a system, this is 5 volt and this is the 0 volt. Okay, now this is bit interval. Okay, now you see how we were representing. Here, what is the meaning for there? Now, here 2 levels are there, here 4 levels are there. So 2 levels means you have understand only 1 bit per second is but here 2 levels mean here what? 1, 1. This is 1 and this is also 1. Here ones and 0, 1 and 0. Okay, and here zeros and 1. Okay, so here what they are saying now, in here 1 second they are sending 8 bits now. Here 1 second they are sending how many bits ma? How many bits? Have you understand what I'm speaking to you? 2 digitals are signals are sending. One signal is sending with 1 level and another signal is sending with 2 level. You have to understand this is 2 level now. This is 4 level. Have you understand this? Students?
Yes, ma'am.
Yeah. So here 8 bits per second. Now here how many bits per second? 8 into 2, what will be the value ma?
16.
16 bits per second. Is clear? So here 2 digital signals are there, one with 2 level. 2 level means ones and zeros. Here you see that it like a looks like an analog signal. We have a 4 levels. Okay. Now one small calculation, then I will end my class. This is
Ma'am,
the,
can you go to the previous slide once, ma'am? I have a doubt, ma'am.
yeah. Yeah, tell me.
Ma'am, in the first diagram, we are calculating even the this thing as a level, ma'am. The axis as a level, ma'am.
Yeah, level 1, level 2.
But in the second diagram, we are not considering the axis as another level, ma'am.
Okay, actually you all understand. They were saying 1, 1. That means 1 second. Actually, when you see this is the entire thing will be 1 second. In the 1 second, in the 4 level, I am transmitting. 4 level means what? 2 level means what, ma? You have a probability of 0,
50,
1,
50.
0, 1. That will be a probability. When you go with 4 level, okay, that will be a probability. They are saying 0, 0, 0, 1, 1, 0, 1, 1. That is 4 level. 2 level means the combination may be 0 or 1. Okay, 4 level means the combination may be 0, 0 or 0, 1 or 1, 0, 1, 1. So that's why here they are saying I can transmit only 1 bit per second. That is, they are saying only 1 bit. So when you take 1 second, it will transmit 8 bits. So 8 bits per second. But while coming to this 4 level, 2 bits can be transmitted at a time. Okay, so when you do that, here when I'm taking 8 into 2, 16 bits per second is transmitted. Is clear on this point? Yes, Srijit? Srijit, are you clear? Where he
Yes,
went?
ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. Here 2 level na zeros are 1 or only probability. Here 4 level they are saying na probability of sending the signal is 0, 0, 0, 1, 1, 0, 1, 1. Okay. I think this is one of the formula to calculate number of bits per level, and 8 a digital signal has 8 levels now. How many bits are needed per level? They are asking your question. Srijit, have you understand? This is the formula to calculate. I think you not needed for the formula. Log to the base n. This formula is very important. Number of level will decides how many bits are transmitted. So they are saying 8 levels. 8 levels means you all know 0 0. What will be transmitted? 0 0, 0 0 1. Okay, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So first level, second level, third level, fourth level, fifth level, sixth level, seventh level, eighth level, 8 levels. So in 8 levels, how many bits I can transmit at a time? How many bits I can transmit at a time? How many
3.
bits I can? Yeah, that is the meaning. 3 bits. This is the calculation. The level decides how many bits are needed for the level. That is very important. Is clear? This is similarly not only this cases. Sometimes it may be not a correct value will get. Sometimes 3.17 they will round off to 4. 9 bits now how many level? This is the way they will round off. Okay, every time we need not to able to do that. Yes, I think I may stop my class here.